Alright, which line of best fit would you use for the given data? Justify your choice. So when you're given A, B, C, how many of you say A? How many of you say B? How many of you say C? Good. Okay, so C it is. Why is this a nice line of best fit? Because it's... Sorry? Yeah?
Because like A has like all the points like on top, B has like all the bottom, and then like C is like
Right. Okay, so C, the line of best fit goes through most of the points and same number of points above and below the line. All right. Does your line of best fit have to go through 0, 0? No. All right. Your line does not have to go through the first point. It does not have to. You're not connecting the first and last point. So the definition of a line of best fit is to mainly have most of the point, to have the same number of points above and below the line. Okay. So again, it does not have to go through 0, 0. Okay. And notice in this graph, does it start at 0, 0? In terms of the scale? Looking at the scale, does it start at 0, 0? All right. Okay. What do you have to use if you need to skip numbers? The zigzag. So this right here. So you see this zigzag? It skipped it from 0 all the way to 110. All right. And same thing right here. They add another zigzag on the x-axis to skip to 125. Sure. Okay. When you do your own graph, remember the scale does matter. So if you're going up by every 10 for each box, you have to be consistent for every single box. Same thing right here. You have to be consistent. If you're going up by 5s or 10 every box, you have to do the same. Okay. The data shows the age and height of the plant. Okay, create a scatter plot. That takes too much time. Okay. Describe the trend. Okay. And explain what this trend means for this situation. So we did an assignment before. Remember how I said in this situation, in the context of the question? So I don't want you to define again what a line of best fit means. I want you to refer to weeks and height of the plant. So as the number of weeks increase, what happens to the height of the plant? The height of the plant increases too. The plant increases. Okay. So this is what I mean by in terms of this in this situation. So number of weeks and height of the plant. Notice I use the title of the two axes. Okay. Using your line of best fit, predict the height of the plant when it's 10 weeks old. So this you would extend your line of best fit, and then use extrapolation. Okay. So that's the trend. So if your graph looks something like this, increasing trend, so your plant increases. If your line of best fit is this way, then that means it's a decreasing trend. Okay. Got it? Got it. Next page. A DVD player has quickly become common in Canadian household. you know how old this question is then. Okay. Graph the dotted line of best fit. Is this the linear or nonlinear relation? So what makes it? So what did you guys say for C? I didn't graph it, but did you say it was linear or nonlinear? Right? Who says linear? Who says nonlinear? Good. Okay, nonlinear. What made it nonlinear? First difference isn't the same, but see, this is where it's a little tricky. Yes, I did teach you guys about first difference. If first difference is the same, then it's linear. But sometimes in a line of best fit, the first difference is going to be different as well. So in this case, we are doing line of best fit, curve of best fit, so you can't use first difference. Yep. Exponential growth. Good. Exponential growth. So how, like when you're doing line of best fit or curve of best fit, the best way to distinguish between them is if it has a somewhat linear growth. So like it doesn't have to be exactly first difference the same, but like somewhat the same growth every step. Whereas nonlinear relation, it grows much more dramatic. So in this case, your line looks something like this, where it's a curve. Okay. Same thing with this. You're gonna use interpolation and extrapolation. Okay. Next page. Right. So again, I'm trying to get through as many questions as we can here, so that's why I'm skipping some questions. Use capital letters. When is Mary at the basket? So this is distance from basket. So Pedro? Point E. Right, this right there. So the basket is over here. Okay. When did Mary stop to tie her shoe? C, because it's a horizontal line. Whenever it's a horizontal line, you know it means they stop. When was she running the fastest? D or F? D or F? D. Why is it D? Steeper slope. Yeah, D. Okay. The more steep, the faster. And let's say you're not so sure, then do distance divided by time. So this is the distance it covered in like 1 minute, let's say. And then this is the distance that it covered in 2 minutes. Okay, so you can actually use numbers, put in numbers yourself to divide. When is she running towards the basket? At F or at H? H, right. Notice the word towards. Yeah, so you're not running down the court. You're not running up the court. You're running towards the basket. So H, you're going back towards the basket, which is down here along this line. So H is towards. And then what happened at G? If you play basketball, you will know. So Annie, I know you play basketball. So this is you after you guys score the basket, and then you go this way, and then you go here. What happened?
What?
Okay, so
That's my net,
this is your net right here.
right?
Your net is at the bottom right here. So after the other team inbound, what are you doing here?
I'm running back to my net.
Yeah, for defense, right? You're going back on defense. And then what happened here? Why are you going back towards your basket? You were playing defense. Pedro? You stole it, and then now you're on offense again.
But isn't that supposed to look that way again?
Your graph your graph would always move this way. You won't go back. So you don't draw your line back over here. Like remember, this is time. So as time goes on, what happened in the game? Yeah. So you were going on defense, and then you guys stole the ball. So now you're going back towards the basket. Yeah. So turnover. So or you stole the ball. Stole the ball. Even if you don't know basketball, it's okay. You can tell that you are going away from your basket, and then you turned and went back towards your basket. Okay. So for this one, I just want to do, for example, E to F. Okay, I just want to do segment E to F. If I want to find the speed between E to F, what happened? How do I figure out speed? What's the formula for speed? Think science. You guys do it a lot of times. Distance over time. Yeah. Distance divided by time. Okay, so just between E and F right here, what was the distance that you traveled from E to F? You have it on your sheet too.
20 kilometers.
Okay, so E to F, this was 90. F looks like it's about, what is it? Every box is 15. So this is about like 130. I think this is about 130. That's 130. So from 90 to 130, what's that? 40. So 40 kilometers. How long did that take? From here to here. So in this one, every box is 10. So 10, 20, 30, 40. So it's 40 minutes. Yeah, that's half a box right here, and this is also half a box. Yeah, so 10, 20, 30, 40. All right. So what's my final speed then? 40 kilometer divided by 40 minutes, that's 1 kilometer per minutes. Right. All right. Make sure speed is 2 units, like this. Okay? It doesn't always have to be kilometer per hour. It could be kilometer per minute. Okay. Yeah, or you could do 60 kilometer per hour too. That's good. Okay. So when you write your units, make sure you read your graph carefully. It tells you the units. Okay. So why I chose EF, because I wanted you guys to see you don't just base it on, oh, this is 130. You're only looking at each section by section. Okay. Next page. Okay, first 3 frames of the pattern are shown. Draw the next 3 frames. Okay, that's pretty straightforward. Okay, and then looking at this, for the next 6 frames, record the number of frames and the number of squares used. So 12, 15, 18. Okay, how many squares will there be in the 8th frame? So I could simply just extend my table because I know that, what's my first difference right here? First difference. How do I calculate first difference again? Yeah, the second row, subtract the first row, so subtracting backwards. 6 minus 3, 9 minus 6, and so forth. Okay, so remember you're subtracting backwards. So that's how I know my first difference is 3, so this is 21, This is 24, so 24 squares. Alright, and then this part says which frame will have 30. Okay, so yeah, I could continue going on, and then I know that this would be the 10th frame. But for the sake of the review, let's come up with the equation as well. Okay, so this one for D is 10th frame, because if I just keep going, 27 and then 30, that would be 9, that would be 10, so I know it's the 10th frame. Okay. Given this table, let's come up with the equation. Y equals mx plus b. Okay, what's m? 3. Is it because my first difference is 3? Difference in x. Yes, good job. So don't just say it's 3 because first difference is 3. You also have to check this side. 3 minus 2 is 1. So 3 divided by 1 is 3. So 3x. What's b? 0. Good. Where did you get 0 from? I don't see 0 right here. Right. So go back one more step to frame 0. 3 minus 3, 0. So on the test, if I write this, will I get full marks? How should I write it? Yeah, simply y equals 3x. All right. You don't need that plus 0. Okay, so now if I say in the 100th frame, how many squares will I need? 300. All right, so you see how once you have the equation, it makes the whole question much easier. I could ask you any frame, any squares, you'll be able to answer with the equation. All right, moving right along. The same idea with these graphs. Yeah, I think you guys know how to graph. Do I need to graph? Because I think it's time consuming. I'd rather take up other questions with you guys. So I think you guys know what to do. Okay. This next page. A small rocket is launched from a hill 500 meters above sea. It rises at 25 meters per second. What is the rate of change? What does this rate of change represent? Okay, so what's my rate of change? Dikshan? Yeah. 25 meters per second. That's your rate. And what does this represent? Sorry? How much it rises per second, or simply you can just say it represents the speed of the rocket. Okay. What about the y-intercept then? What is my y-intercept? 500 meters. And what does it represent in this question? Starting value, where it starts. Where the rocket starts. Okay. Write an equation for the relation between the height and the rocket of the rocket and time. So again, y equals mx plus b. So your equation will simply be y equal 25x plus 500. That's it. Right. So now if I say after 10 seconds, how high is that rocket? So let's say I add in that part D. How high after 10 seconds? Okay, how'd you get that? Yeah, good. And so you get 750 meters. Good. Okay, don't forget units. So this is like the kind of question you'll definitely see on the test. Given this, so like for example, given this one small sentence, come up with the equation, and then how high after 10 seconds, or after when will it reach 500 meters or something like that. Okay, so you'll see those for sure. Oh yeah, good question. I let me I'll answer that after the review. Okay. Okay, given the table of value, determine the rate of change. Okay, yeah, we could do this one. So determine the rate of change. What is my first difference here? 2. All right. What about the first difference in? What about the difference in x? 1. So my slope is. Good job. So it's 2. 2 divided by 1. So it's 2. What's my y-intercept? 3. Good. When x is 0, what is y? It's 3. So the equation y equals. That's it. Hey, nice and easy. So this is given a table, come up with the equation. This one, given a word problem, come up with the equation. Okay, so sorry, let me give you guys a second if you need to copy that. Okay. This. Okay, analyzing graphs. So given the graph of a heart rate with respect to age. Okay, so determine the slope and what it stands for. So in this graph, you're given 2 points, this and this. What's the coordinate of this point? Sorry? 0 to 100, good. What's the coordinates of this point? 80 and 120, good. All right, so determine the slope. We can either do rise over run, or we can do the slope formula. So we could either do this, or we can do this. Same thing, same idea. You're basically finding the difference between the y value and the distance over the x values. So what's the difference here? Since I'm given a graph, let's do the rise over run.
80.
Okay. And the run?
80.
Mm-hmm. All right. But what's wrong with what I wrote? It's not 80 over 80. Negative. You went down 80. So negative. And how I know it's wrong as well? Direction of my line. It's this way. It's decreasing. So I can't have a positive slope. It's a negative slope. So negative 1. Right? My slope is negative 1. What's the unit? Oh, this is a little tricky because your y value is that. So negative 1 beats per minute per year. Okay, so it sounds weird because it's per and then per again. So BPM per year, basically. Okay. In terms of a sentence, what does it mean?
Every year your heart decreasing.
Decreases by 1. Right. All right. Remember, this is maximum heart rate versus age. So it means that every year, the maximum heart rate decreases by 1. Good. All right. Determine the y-intercept and what it stands for. 200. 200 beats per minute. And what does it stand for in a sentence?
The heart rate of an infant.
Good job. A heart rate of a newborn. Okay, so at 0 years old, that means as a newborn, their maximum heart rate is 200. Okay. So right now, if you have a 200 beat heart rate, we need to call an ambulance. Okay, you should only reach 200 as an infant. Okay, and do you guys know why your heart beats so fast as an infant?
Because we haven't developed yet?
Well, because as a baby, you need a lot of blood pumping to all parts of your body, so that's why it's like beating so fast. It's pumping blood to the rest of your body.
But they're tinier.
Yeah, but they don't have anything else to produce, so like their functions is still not working everywhere, so they need all the blood. Okay, so as a newborn. So newborn baby, that's the max. Okay, write the equation for this line. So y equal negative. Yes. Okay, I don't want to see that 1 as well. So just like I don't like to see that plus 0, I don't like to see that minus 1. Okay. Write the equation of the line with a slope of 2 and y-intercept of 5. Okay, so that's easy. 2x minus 5. Okay, write the equation of a line with slope negative 3 and going through this point. So math. We have to do some math here. This is my m. You're thinking about newborn and babies and that now. See the things that we talk about in math class? I need a disclaimer. Alright, so you're given this point, so the x and the y, and that's your m. So what are we trying to solve for here? B. No, we have slope. We need b. Okay, so Annie, what is y?
Negative 4 equals negative 3, open bracket, 2, close bracket.
Good. Okay, I love that you said the brackets as well, because without the brackets, you'll think it's negative 3 plus 2 or negative 32. You need the bracket so that you know you're multiplying. So negative 4 equals negative 3 times 2 is negative 6. So when you move that negative 6 over, it becomes negative 4 plus 6, which is 2. So what's my equation?
Negative 6 plus, negative 3 plus 2.
Does it? Alright, remember you are given m.
Right.
Alright, so this is here. This that you just found goes here. Alright. So this is like the only kind of calculation you need for the whole test. I think so. Yeah, this is the only actual calculation you need to know. Okay, well, this is calculation, but it's not hard calculation. Find the x and y intercepts. How do I find x and y intercept? Yeah. Okay, so your two sides. To find y-intercept, you're going to let x equal 0. Okay. So when y is 0, that means that's gone. So you're just left with negative 6x equals negative 8. Right? Anything times 0, that's gone. So that's why it's just negative 6x equals negative 8. So when you divide it, what's negative 8 divided by negative 6? 4 over 3 and positive 4 over 3. Okay, so what's my coordinate here? And 0. Good. Okay, which is, if you were to graph it, is about like 1.3. Okay. Same thing on this side when x is 0. So that means this is gone, and you're just left with 2y equal -8. So when you divide it, you get -8 divided by 2, -4. What's my coordinate here?
0, -4.
0, -4. Good. Okay, graph the line using the intercepts. So, okay, let's graph it really fast. Okay, 0, -4, 1, 2, 3, 4. And the other one was 1.3 and 0. Okay. Okay, this is my line, x-axis, y-axis. Okay, so I have this. Determine the slope and write the equation of the graph. So should I still use these 2 points to do my rise over run? Should I use these 2 points? I don't think this is a nice point to use. Right, 1.3. This point is a nice point to use. What's another nice point on this line? 1, -1. So why not use this point? Make your life easier. This point and this and this. Use these 2 points instead to find your slope. So my slope, what's my rise?
3.
What's my run? Yeah, so my slope is 3. So instead of using this point to this point, if I use these 2 points, my rise would be 4, and then my run is like 1.3, which is not a good point to use. Remember, you can choose any points on that line. And what's my y-intercept? -4. So my equation, y equals, that's it. Okay, and yeah, so it's not 3x plus -4, it's just 3x minus 4, like that. Right? And if you did use the 4/3, which is 1.33, so if you do rise, which is 4 divided by 1.3333, you'll also get 3 as your slope. So either way, like if you did use this point, you'll also get 3 as your slope. Okay. These ones, inequality. This is as I said, when we did this lesson, this is the new thing on EQAO. And last year, they asked quite a few of these. So make sure you pay attention to this. So put those phones away. Okay, I want to make sure that we know how to do these. Use sets of axes and with x and y values from -6 to 6 to show the region which the following inequalities satisfy. So I'll just do two. I'll do 2 of these. Okay, so if let's say this is y equals x. I know it's an inequality, but if you think of it as y equal x as the equation, can you come up with the table? So when x is 0, what's y? 0. When x is 1, y is? When x is 2, y is? Yeah, and so forth. So your graph for y equals x is like this. Okay, so this is x, this is y, and this is your equation, y equals x, like this. Now, but because it's an inequality, I don't want just a straight line. I need to shade in. So y is greater. So y is greater means I need to shade in which part? Top part. Right. So when it's greater, that means I shade in above my line. Oh yeah. So they just want like from like here to here. Yeah. Between -6 to 6, something like that. Okay. This y equals x plus 2. So if I were to graph this, alright, so this is my x-axis, this is my y-axis. So y equals x plus 2. What's my y-intercept? 2. Alright, what's my slope? My slope is 1, not x. My slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1. Alright, am I going to draw a line now? Dotted line. Why is it a dotted line?
Greater than the line.
Or equal to, right? So notice this. So you see the difference between this symbol and this symbol? Alright, this means equal to, so I have the solid line. This one is only greater than, so I draw a dotted line. Okay, and any, which part do I shade in? Top part or bottom part?
Bottom part.
No, y is greater. Top part.
If it's less than, then it's bottom.
Yeah. Alright. This one, Michaela, you're gonna help me with this one. Y equals x minus 1.
Less.
Yep, y is less than x minus 1. So looking at this equation, what's my y-intercept? What's my y-intercept? Okay, so pretend that the equation is y equals x minus 1. So forget about that symbol first. So if I just give you y equals x minus 1, what's my y-intercept? Not just 1, but -1. So I plot that point first. Okay, at -1. And then what's my slope? Sorry? The number in front of the x. 1. Okay, so no x. Your slope is just a number. So 1. So up 1 over 1. Up 1 over 1. Up 1 over 1. So there's my line. Now I look back at my equation. Alright, now I look back at my equation. It's y less than x minus 1. Not yet. Okay, y less than. So should I do a solid line or dotted line? Dotted because there's no equal to. So dotted line, connecting those points, and is this. Okay, this is the equation. Less than, so it's a dotted line. Y less than. Should I shade in the top part or bottom part? Bottom, because it's less than. So I shaded that. What about these ones right here? Given the graph. Alright, given the graph, what is my y-intercept? What's my slope? 1. Alright, so the equation is y equal x plus 1. Alright, since I shaded the bottom part, less than or equal to, because it's a solid line and I shaded in the bottom part. I don't know. Yeah, and this is something new that they just threw in.
Less than greater than equal to it. don't know that we have an equation.
Wait, is it really test?
Yes.
I don't know. We didn't used to need this.
Didn't we just do it, like, start doing it from, like, last year?
2 years ago, the new curriculum. Yeah. Okay, but anyhow, and they don't only ask one question; they ask a few on equilibrium. Yeah. So, but if you get it, then those should be free marks for you. Okay. Equation of this line. What's my y-intercept? Yeah, right here. What's my slope?
1 over like
2, right. So if I use this point and this point, rise 2 over 1, so 2. So my equation, y, 2x plus 0. Greater. Good job. Okay, and only greater because it's a dotted line, and since I'm shading the top, that's why it's greater. Okay, let's just try, let's just finish up these two. What's my y-intercept? 5. What's my slope? -1. Remember direction of your line, -1. Okay, so y, and then -x plus 5. What symbol? Less than or equal to, because you're shading in the bottom part, so it's less than, solid line, equal to. Okay. Okay, so are we good with these? Okay. Let's keep going. I know I'm talking a lot today because it's a review class. I want to make sure we go through everything. Guys. Okay, number 3. Okay, number 3. Okay, Pool A charges a yearly rate of $50 and $4 each time to swim. So can we come up with an equation for Pool A?
4x plus 50.
So y equal
4x plus 50.
4x plus 50. Guys, Annie, Pool B. Can you come up with the equation? Pool B charges a yearly rate of $200 and $1 each time to swim.
Pool B, y equals 1x plus 200.
Good. Yeah, good. You have to be able to tell the difference between the slope and the flat rate. Okay. What advice would you give somebody who wants to swim 75 times? So to swim 75 times, not equal 75. You're gonna sub in 75 in here and figure out how much they need to pay at each. So 4 times 75 plus 50.
350.
350. So $350 at Pool A. What about for Pool B? Y equals 1 times 75 plus 200. So 275. So which one is cheaper? Pool B. Alright. Oh, the sum of two integers is 26. The difference of the two integer is 4. Find the two integer. Alright. So if I were to write the equation for this, sum of two integer is 26. What's my equation? Yeah, x plus y equals 26. What's my second equation? The difference of the two integers is 4. Perfect. All right. And then you would have to graph these two lines to see where the intersection point is. And then that would be your two integers. Okay, so this, based on what we know, what we've learned in grade 9, we would have to graph these two lines in order to find the equation. Before I can graph this is in standard form. So what do I have to do? Convert it to y equals mx plus b. So this would become y equal negative x plus 26. And this equation would become y equals x minus 4. Okay? And then you would graph it. Yeah, because this is negative y. So then when you graph it, you'll find the intersection point, and then that would be your two integers. Do these two lines intersect at this? So this is your x, this is your y. So what you want to do, substitute it in the equation. 2 plus 3 gives you 5. So yes with this one. But what about here? 3 times 2 is 6. 6 minus 7 is negative 1. So nope. You don't get the 3, you get negative 1. So that means they don't intersect.
For 4, like when you graph it, like how does that help you find the two integers?
Because you're looking for the x and y value that satisfy both equations. So that's why the intersection point is the only point where it satisfied this condition and satisfied this condition. Okay. Determine the slope and y-intercept of this line. So what we were saying, we have to rearrange it to y equals mx plus b. So okay, we want it in this format. So changing it, 8y equal. Move that negative 7x over, becomes 7x. Move that negative 16 over, it becomes plus 16. Okay, divide everything by 8. So y equals 7/8x plus 2. What's my slope? What's my y-intercept? Good. Okay. Are they collinear? Same thing, just find the slope between this, slope between that. On the test, make sure you know the slope formula. y2 minus y1 over x2 minus x1. Okay, this one, Cruising Coaster Park charges $875 for a group of 25 people, $1,400 for a group of 40 people. What is the rate that they charge per person? So notice here, you're given 4 numbers. You're given 4 different numbers. So you want to rewrite this part as a coordinate. How do I write this as a coordinate? Close.
25, 8, 5.
Why is it this way?
Because it's like on like a graph, it would be like people 0.9.
Yeah, so your number of people is the independent variable, dependent variable. And then this part, can I write this as a coordinate?
40, 1400.
Yeah, 40 and 1400. Okay, and then you would do the slope formula, and that's how you find out the rate. Okay, last one. Let's see. Is there any more after this? Oh yeah. Okay. So I want you guys to take 5 minutes. Do this. Number 10. This last question right here. Take 5 minutes. Do this one, and then we'll take it up. Solomon earns $9.25 per hour in a pizza shop. 17 as a waiter. He earned $5.73 in a week. Okay. Okay, so try this one now. I know not everybody got through the whole package, so this is the last question. I want you guys to try this one. So explain why this equation models this situation. What does x represent here? Petro. Right. So it's not enough to just say number of hours. You have to say hours worked at the pizza shop. And then what would y represent then? Number of hours worked as a waiter. Okay. Is this relationship linear? Looking at just the equation itself, I can tell that it's linear because, sorry? No exponents? Slope standard equation, standard form. Okay, good. Determine the x and y intercept. So we said to find the x-intercept, we let y be 0. To find y-intercept, we let x be 0. So if we graphed it by hand, we should get this answer. 0 and about like 34. We'll say about 34. And this one, it will be 62 and 0. So what does this 0 and 34 mean? Yep. Just as waiter. Good. Okay. Just as, so 0 hours at the pizza shop and 34 hours as waiter. Similarly, this one would mean not working at the waiter at all, not working as a waiter at all, and then only 62 hours at the pizza shop. Okay, and one possible answer of him working at both places could be, for example, this right here. Oh no, that's not the best one. This one. Yeah, so like about 25 hours at the pizza shop and 20 hours at the as a waiter. Okay, so any one of these points, any points on that line, is a combination of him working at both. So, for example, this one is a nice point. So 50 hours at the pizza shop, 6.5 hours as the waiter. Okay. Sorry? Yeah. The slope is negative, but in this case, the negative is because the more hours you work at one place, the less hours you can work at the other. So that's why it's a negative relation. Okay. Don't forget to check the homepage. On our homepage, it will say what are the topics you need to know for tomorrow.